Dear students, this is our 12th lecture on medicinal chemistry, and today we will discuss about antipyretic drugs. And under antipyretic drugs, we will explain what are NSAIDs, non-steroidal anti-inflammatory drugs. Now, as far as definition of antipyretic drugs is concerned, the word antipyretic is consisting of two words. Anti means against and pyretic means feverish. So any compound which is used to decrease fever is antipyretic. Pyretic means feverish. So any antipyretic is a substance which reduces fever, and the mechanism of reducing fever is basically what happens in our body is that some enzymes, they produce these types of substances which are called as prostaglandins in the body, and this production of prostaglandins is catalyzed by some enzymes which are known as cyclooxygenase enzymes. Now when these prostaglandins, they are produced in the body, they will increase the temperature of the body, to which we call it as a fever. So when we will give antipyretics, what they will do, they will inhibit the activity of those enzymes which are producing prostaglandins. Therefore, prostaglandin formation will be stopped by these antipyretics, and the body will then work to lower the temperature, and there will be a reduction in the fever. So this is how these antipyretics they work. Now antipyretics may be of different types, and most common antipyretics which we use, they are aspirin and ibuprofen. And the category under which these antipyretics they are there, ibuprofen and aspirin, these are called as non-steroidal anti-inflammatory drugs or NSAIDs. And these NSAIDs, they are primarily used as anti-inflammatory agents or analgesics. Analgesics means pain relievers. Anti-inflammatory means the substances which will reduce the inflammation in the body. And in addition, these NSAIDs, in addition to anti-inflammatory and analgesic properties, they will also have the antipyretic properties. Antipyretic means they will reduce the fever also. So ibuprofen and aspirins, this is the structure of ibuprofen and this is the structure of aspirin, acetyl salicylic acid. These are the examples of non-steroidal anti-inflammatory drugs. Similarly, another common substance which is used is paracetamol. Now paracetamol, or this is acetaminophen, which is called as, this act as an analgesic only. It relieves pain, but it does not reduce the fever, because this is not having anti-inflammatory properties. Now, as I have told you that NSAIDs are the drugs which reduce pain, they decrease inflammation, and they decrease fever. And in addition, they will also prevent the formation of blood clots in the body. But in addition to acting as anti-inflammatory agents, antipyretic agents and analgesics, they have some side effects also, and these side effects, they depend on the type of specific drug which we are using, which means the ibuprofen will have a different side effects in comparison to aspirin, or paracetamol All these, they will have some specific side effects based on that specific drug, and these side effects may depend on that how much dose we are using, for how much duration this anti-inflammatory agent or NSAID is being used, and the side effects which are commonly present in NSAIDs, that is, they may cause gastrointestinal ulcers. Then there is a possibility of causing bleeding in the different parts of the body. Then there is a possibility of heart attack also, that the patient may undergo heart attack if we have an overuse of the NSAIDs. Then they may also cause kidney diseases if NSAIDs they are used more than the required dose and duration. Now, as far as mechanism of action of these non-steroidal anti-inflammatory drugs is, as I have told you earlier also, that in the body cells, they synthesize arachidonic acid, and this arachidonic acid, in the presence of cyclooxygenase enzyme, which consists of two isoenzymes, that is cyclooxygenase 1 and cyclooxygenase 2. So in the presence of the cyclooxygenase 1 and cyclooxygenase 2, arachidonic acid is converted into different types of prostaglandins, and formation of these prostaglandins is the cause of pain, inflammation or fever in the body. So therefore the NSAIDs, they will inhibit the activity of these cyclooxygenase enzymes, that is COX1 or COX2. When NSAIDs, they act on the active sites of these isoenzymes, they will inhibit the formation of prostaglandins. Therefore, these diseases will be recovered in the body. So, we can use different types of NSAIDs. Non-selective NSAIDs. Non-selective NSAID means they will act on COX1 as well as on COX2. Whereas we can use COX2 selective NSAIDs, they will act only on the activity of cyclooxygenase 2 isoenzyme, but they will not affect the activity of COX1. So this is how different types of NSAIDs, they act in the body. So as I've told you, the anti-inflammatory drugs which we use, they are of two types: non-selective. Non-selective means they will inhibit the activity of both COX1 and COX2. Whereas other category of NSAIDs is which will affect only the activity of cyclooxygenase enzyme 2. Now, the non-selective NSAIDs, they will reduce inflammation. They will also inhibit platelet aggression, but they will increase the risk of gastrointestinal ulcers and bleeds in the body. So these are the two major side effects of non-selective NSAIDs. Whereas if we use COX2 selective inhibitors, then there will be fewer gastrointestinal side effects, but they will promote thrombosis, that is, blood clotting will be promoted because of the use of COX2 selective inhibitors. And some of these COX2 selective inhibitors, they will substantially increase the risk of heart attack also. So as I have told you earlier also, the specific type of NSAID will have a specific type of side effect in the body. Then they all NSAIDs, they increase the risk of kidney diseases because they will inhibit the physiological COX activity in the body. And in addition, NSAIDs can blunt the production of erythropoietin, which will result in anemia in the body. So therefore, in addition to these NSAIDs, we have to give medication for reducing the anemia in the body also. Now, as far as classification of different types of NSAIDs is concerned, as I have told you, some NSAIDs, they have only analgesic properties. That is, they are antipyretic compounds with poor anti-inflammatory properties. And examples, they are paraminophenol, example is paracetamol or acetaminophen. Then nefopam is the other example where we are having benzoxazosine ring present in the structure of the compound. So these types of nefopam and paracetamol, they are the examples of analgesics which can be used, and these will have good antipyretic property but poor anti-inflammatory property. The NSAIDs with good anti-inflammatory properties, they are preferential COX2 inhibitors, selective COX2 inhibitors, or non-selective COX2 inhibitors. Preferential COX2 inhibitors means they will preferably inhibit the activity of cyclooxygenase enzyme 2, but they will also inhibit the activity of COX1. So the majority of the activity of COX2 will be inhibited by these types of substances, and the common examples, they are aceclofenic, nimesulide, nebumetone, meloxicam. All these are the examples of preferential COX2 inhibitors, and these types of anti-inflammatory agents, they have this carboxylic acid functional group, secondary amine, and ester functional group, for example in aceclofenic. In case of nimesulide, we have sulfonamide moiety and nitro group present in addition to aryl ether linkage. Then in these, again sulfonamide moiety, amide moiety, and thiazole ring is present. Whereas in this case, we are having ether linkage and ketone function group as the active functional group for the activity of these types of compounds. Then second category is selective COX2 inhibitors. They will inhibit only the activity of COX2 isoenzymes, and they will not affect the activity of COX isoenzymes. So these are also called as coxib type of anti-inflammatory agents. So example is atrocoxib, celecoxib, and pericoxib. All these, they have similar type of activity, that they will inhibit the activity of COX2 isoenzymes. And here also you can see this is having sulfoxide functional group, then pyridine ring, here also pyridine ring, then heterocyclic ring, over here sulfonamide function group, here also sulfonamide function group, and diazo compounds. These are the CO2 selective inhibitors. Then non-selective CO2 inhibitors are where they will inhibit the activity of COX1 as well as COX2. The structure of all these types of non-selective CO2 inhibitors is given in the next slide. So for example, these are salicylates, example is aspirin. Then propionic acid derivatives, this is one of the most commonly used, ibuprofen. Naproxen is also used, ketoprofen is also used. All these are derivatives of propionic acid derivatives, which can act as non-selective COX2 inhibitors. Then anthranilic acid derivative, mefenamic acid is one example. Then aryl acetic acid derivatives, this is also most commonly used, diclofenac and aceclofenac. These are the two most commonly used anti-inflammatory agents these days, aceclofenac and diclofenac. And aceclofenac is very safe also in terms of side effects. Then oxycam derivatives, pyroxicam and tanoxicam, these are the two most commonly used anti-inflammatory agents. And here also we are having sulfonamide functional group, which is active in addition to the pyridine ring. Then indole derivative, indomethacin is one of the most common anti-inflammatory agent under this category, which is used. Here also again carboxylic acid functional group in addition to indole derivative. So in most of these non-selective COX2 inhibitors, we will see that carboxylic acid functional group is the most common functional group present in these. Then some heterocyclic cyclic derivatives like pyrrole derivatives, they are there. Here also, in addition to pyrrole, we are having carboxylic acid. Then phenylbutazone, oxyphenbutazone, and propylphenazone. These are another category of heterocyclic ring compounds which are used as non-selective COX2 inhibitors. So here we are having this type of uh, pyrazolone ring, which is responsible for the anti-inflammatory activity of these types of compounds. So these are the references which have been used in preparing this lecture. Thank you very much.